I want to compare elastic and inelastic collisions. So when we're looking at elastic and inelastic collisions, you need to know the difference between an elastic and an inelastic collision. So an elastic collision is where objects rebound and the kinetic energy is conserved. So what that would look like is this. I have two balls, they bump into each other, and then they bounce off each other in the opposite direction, kind of like Newton's third law. And an inelastic collision, the objects stick together and the kinetic energy is lost. So in that situation, I've got a big ball, a little ball, they're traveling in the red ball bumps into the blue ball and then ends up shoving the blue ball in the direction it was still traveling. So that's inelastic. They're sticking together and they're going to continue moving in one direction rather than bouncing off each other and continuing in two directions. So let's look at an example. I have the Juggernaut, I have Spider-Man, I have the Juggernaut's mass, I have Spidey's mass. They're both moving at different speeds. So I'm going to go ahead and I'm going to solve for what's going to happen in this situation. Now, my first question is who wins? I think it's pretty obvious the Juggernaut's going to win in this situation. He's got more mass and he's moving at a faster speed. So this is going to be an inelastic collision. Juggernaut's basically just going to cream Spidey and just like slam Spidey into the left-hand side of the frame. Okay, so he's just going to keep going. So we're going to use that same calculation that we did for inelastic. So Juggernaut's carrying Spidey off to the left. We're going to do m1 v1 plus m2 v2 equals the total mass times the final velocity. So we're going to work through that. And that's going to give us a final velocity of 18.25 meters per second to the left. So the Juggernaut ends up slamming into Spidey and just carrying Spidey off to the left-hand side at a speed of 18.25 meters per second. That's an inelastic collision. They stick together, okay? Let's look at an example of an elastic collision. That's going to be a little harder to find an elastic collision with the Juggernaut because he's so big. So we've got the Juggernaut, 225. He's moving at 25 meters per second. It's time for you guys to meet Colossus. Colossus is only moving at 10 meters per second, but his body's made of steel. So he actually has a much larger mass. They're approximately the same size, but you know, metal's heavier than flesh. So he's got a much bigger mass. So what happens there? They're going to bump into each other, and then they're just going to bounce right off of each other. And because these guys are arch rivals, I'm going to have them be fairly well matched, and we're going to have it be a completely elastic collision. So the Juggernaut's actually going to bounce off at the exact same speed that he runs into Colossus, which I think most of you can see means that Colossus is going to bounce back at the exact same speed that he bumps into the Juggernaut. But we're going to prove that mathematically. So we're going to do this full equation using the initial velocities for both of them and the final velocities for both of them. Their masses don't change. And so we're going to plug in. And what we're solving for is Colossus's final velocity right there. And we're going to go ahead and we're going to plug in. If you notice, at the beginning I have the Juggernaut going negative 25 meters per second. But on the opposite side of the equation, on the right-hand side of the equation, Juggernaut's going 25 meters per second. And that's because he starts off going west, but then once he slams into the Colossus, he ends up bouncing back towards the opposite direction. So that's going to change the sign of his velocity. So let's solve for that. And we get a bunch of 5, 6, 2s, and 5s. And so we're going to go ahead and we're going to get negative 5,625 equals 562.5 V. So when I solve that, I just get that Colossus is going 10 meters per second towards the left. So he bounces off at the exact same speed that he started, but in the opposite direction. And that's it. That's a completely elastic collision. You've got two completely matched opponents. They bounce off at the exact same speeds that they ran into each other. It's not always going to be that exact same velocity, but the calculation for an elastic collision is always going to work that same way.